Good day everyone. Today you will learn how to identify the differential equations. That is, to which type it belongs. First you should know before proceeding further. You have studied there are four types of differential equations. First is variable separable, second homogeneous, third is linear, and fourth is equations reducible to variable separable. These are the four types you know. Now, what is the order in which we are going to find out to which type the differential equation belongs? Actually, first you have to check whether it is homogeneous or not. That is the first thing you have to check. So, in homogeneous, there are two types we can say. That is broadly categorizing. Supposing all the terms are in algebraic expressions, you check the degree. If the degree of each term is same, you can say that differential equation is homogeneous differential equation. In case it contains some trigonometric functions like sine, cos or tan, or if it is some logarithmic function or exponential function, in that case there should be either y by x or x by y in the angle part or in the logarithmic part or in the e power, then it definitely belongs to homogeneous, otherwise it doesn't belong to homogeneous. So first check whether the given differential equation is homogeneous or not. Okay, if it is homogeneous, proceed. Otherwise, the next thing you have to check is variable separable. That is, whether you are able to separate the x terms and dx on one side and the y related terms and dy on the other side. So you check that one. If it doesn't belong to these two, then come to whether it is a linear. If it is of the format dy by dx plus py is equal to q, where p and q are functions of x, then it belongs to linear differential equation. If it doesn't belong to any of the three, we have to try whether it belongs to equations reducible to variable separable. You will substitute something, after that it will become variable separable. So this is the order, okay? So actually this is the first one you will try, then you will try this, then you will try this, and then you will try this. This is the order in which you are going to proceed. Some sums, it will be very straight, no? We will be able to find whether it belongs to a particular type easily. Certain sums, we have to do one or two steps and then only we will be able to find. Now let us see how we are going to identify. Now see here, you are having now 9 sums. Let me just read them. Xy minus x squared into dy by dx is equal to y squared. X squared minus yx squared dx plus y squared plus x cube y squared dy is equal to 0. Then the third one is cos of dy by dx, that is equal to a. The fourth one is x squared plus 1 into dy by dx, that is equal to 1 by x squared plus 1 the whole squared minus 4xy. dy by dx plus 1 is equal to e power x plus y. The sixth one, 3xy plus y squared into dx is equal to x squared plus xy dy. 7. E power minus root 2x by root x minus y by root x into dx by dy is equal to 1. 8. 1 plus e power x by y dx plus e power x by y into 1 minus x by y dy is equal to 0. The last one is 1 plus x squared into dy plus 2xy dx is equal to cot x dx. Now, first let us take the sums in which there are only algebraic expressions. You can take sum number 1, sum number 2, then here there is some constant, so we can take sum number 6, and then that's all. Only these 3 sums contain only algebraic expressions, no constants and no trigonometric function, no logarithmic, like that. Now first, let me take the first sum and tell you. Let us take each term. Xy, it is of degree 2. X squared degree 2. Y squared degree 2. So definitely I know this belongs to homogeneous type, right? So it is easy, we can identify. Then you come to sum number 6. You see the terms x, y, that is second degree, y squared second degree, x squared second degree, x, y second degree. Okay, so all the terms are the same degree, so this is also homogeneous. So I can mark it, I can easily identify this. Now the second one, if you check, you have x squared, you have yx squared, this is of degree 3, this is of degree 2, this is degree 2, here this is degree 5. So definitely it does not belong to homogeneous. So I have eliminated that chance. It is not homogeneous. Okay, what is the next thing I will try? I want to try whether it is variable separable. Now, see here, you have an x squared common. You can write it as x squared into 1 minus y. Here y squared is common. You can write y squared into 1 plus x cube. So both the brackets you are able to split as multiples of x term and y term. So definitely this will belong to variable separable type. So first we have taken only the algebraic terms which differential equations contain like that, and now we have found out to which type they belong. Now the easiest one which I can find is, if you check at the 8th sum, you have some exponential function, right? Now you see e power x by y. Here also you have e power x by y. So no thinking at all. Straight away you can say this belongs to homogeneous. Okay? But you should remember, if it is y by x, you have to use that dy by dx is equal to, and you will write y is equal to vx. If it is power x by y, you have to take it as dx by dy and put x is equal to vy and then proceed. You know all those types. So now 4 sums we have now finished identifying. So the next thing, I am just thinking of the third sum. If you see the third sum, you have got, for the dy by dx you have a cos function there. So I cannot proceed. So what I will do, I can write cos of dy by dx is equal to a as, I can write dy by dx is equal to cos inverse a, right? So you know cos inverse a is a constant. You keep the dy here, you take the cos inverse a here and dx here. So now you know it is variable separable. Actually you don't have a y term, you don't have an x term, but still it is variable separable. So you can integrate both sides, keeping the cos inverse a outside the integral because it is a constant, and then you will get the answer. So now this sum, even though it is not straight away, you cannot find it as variable separable. After this step, you know it belongs to variable separable. Okay, so the third sum is over for you. So that is how you have to analyze each sum and find out. Now let me come to the fifth sum. If you see the fifth sum, there is some exponential and I don't have a y by x or an x by y, so it is not homogeneous, right? Then I can try for variable separable. E power x plus y, I can write e power x into e power y, correct? But here I have a 1. So that makes my variable separable not possible here. So now what I will do is, I will substitute that x plus y as some t, okay? Then it will become equations reducible to variable separable. That is, put your x plus y as t. You differentiate now with respect to x, 1 plus dy by dx, that is equal to dt by dx, or your dy by dx will become dt by dx minus 1. You take this 1 here, so I will get for this dy by dx, dt by dx minus 1. That will be equal to e power t minus 1. Okay, and then you can proceed. It will become a variable separable type. So it is equations reducible to variable separable. Okay, so this is equations reducible to variable separable type. So that is over for me. Now you come to the ninth sum. If you look at the ninth sum, you have one term with dy and two terms with dx. First, unless you have to combine the two dx terms, you may not know to which type it belongs. Straight away you won't be able to find. So first what we can do now, we can write 1 plus x squared into dy, you keep it. You have plus 2xy dx. You bring this cot x dx here. So minus cot x dx, that is equal to 0. So I will get 1 plus x squared into dy, okay, plus dx I can take here. I will get 2xy minus cot x, that is equal to 0. So now I actually want like dy by dx format. So I will keep this term here. I will take these two terms there, or I can change the sign. So I will get cot x minus 2xy dx. So dy by dx will be equal to cot x minus 2xy by 1 plus x squared. Now let us write it properly. I will get cot x by 1 plus x squared minus 2x by 1 plus x squared into y. You bring this term to this side, you will get dy by dx, okay, plus 2x by 1 plus x squared into y. That is cot x by 1 plus x squared. Now see, this is of the format dy by dx plus py is equal to q, where the p and q are functions of x. So this belongs to a linear. But unless you do a few steps, you may not know whether it belongs to linear or not. But one thing is, you can first itself eliminate it is not homogeneous, because you have a cot function, you have a 1. Then it is not variable separable, because you won't be able to split it. That is why I am trying by this method, and I get it is a linear type. Okay. Now, what are the sums now left now for us? Now we have 1/7 sum and we have the fourth sum, right? Now let us see the fourth sum. In the fourth sum, there is a dy by dx, but you have a coefficient before. Definitely this is not homogeneous, because I have a 1 here, okay? A constant is there. And variable separable may not be possible for me, because there is some minus, there is some x term, xy and all. So first what I am going to do is, I am going to divide this equation by x squared plus 1. So I will get here dy by dx, right? Then here I have already 1 by x squared plus 1 the whole squared. If I divide it by x squared plus 1, I will get 1 by x squared plus 1 the whole cube. Then minus 4x by x squared plus 1 into y. Now see, you can bring it this side. It will become dy by dx plus py is equal to q format, where your p and q are functions of x. So this also belongs to linear, right? So now only one sum is there for us. Let us see that. That sum is, you have e power minus root 2x by root x minus y by root x into dx by dy is equal to 1. Definitely it is not homogeneous, because you are having an e power and you don't have an x by y or y by x. And it is not homogeneous. I mean, it's not variable separable, because you won't be able to separate the x and y from here. So now you bring this dx by dy to the other side. That will become dy by dx, correct? So you will get a dy by dx, that is equal to this one. Now take this term to the other side. So it will become again a linear, where dy by dx plus py is equal to q format, where your p and q will be functions of x. So this also belongs to linear. So have you understood how to go about and how to find to which type each one belongs? First check whether it is homogeneous, okay? Then next step, you check whether it is variable separable. Then you come to linear. Linear means there should not be any coefficient for dy by dx. And if the three are not working, you can check whether it is equations reducible to variable separable. Hope you have understood this. Thanks for watching the video. You can subscribe and you can click the bell icon to get notifications of further videos. Thank you.